Normally when I do these videos, I go through the software development lifecycle. I've adjusted it slightly to be specific to the game development lifecycle. It's the same principles and it's the same phases. It just takes into account a few extra components because game development is a combination of software and visuals as well as a bit of sound and other media aspects. Also take into account that the previous two videos included an introduction to game development where I discussed the different roles involved in making games, as well as the process, the actual software development lifecycle that we're talking about. And then we went through the first phase, which is establishing a solid premise. The premise being something that we're going to use at every other phase of development as our reference point. So you'll see as I reference it and go back to it throughout this video. So what we're going to cover today, we're going to talk about turning goals into objectives. So we establish what our main goals are during the premise phase. We're going to break those down into more digestible chunks. We're going to talk about effective prioritization. It's important to understand where your priorities are, which objectives need to be achieved, and sometimes in what order. We're also going to talk about anticipating the amount of effort required to complete tasks. It's helpful when establishing SMART targets and saying whether or not you'll be able to accomplish what you set out to do or the timeline that you might be working with. I think it's also important that we discuss standardization and some naming conventions. This is because a lot of these videos that I do are based on feedback that I got while I was training apprentices as a skills coach. And this was one of the areas that most students struggled with. And this is not just students, but it's apprentices, junior developers, people who, for the most part, worked independently and never really considered the importance of good naming conventions until they got into the work environment and it became a big deal, and it just makes that first couple of months just more difficult, and sometimes years depending on how badly you screw up. So let's go to the next step. Turning goals into objectives. So a goal without a deadline is just a dream, essentially. You need to identify clear aspects of your goal, and we're going to talk about the SMART approach to doing that. But with games development, your goal is usually something very grand, and you usually have more than one. So in this case, I refer to them as milestones. They are the main stages of development that let you know how far along in a project you are. Your core features are going to always be a key milestone. Regardless of the game that you're making, there are certain things that are always going to be there, such as a game over screen, a victory scenario, the interface, controls, tutorial, text, sound, visuals, basic code, that kind of thing. And then depending on the type of game, there'll be some features that might be unique to your game, but they are still considered core features. They're not considered like bonus features. So that might be things like, if it's a driving game, you're going to need driving mechanics. If it's a fighting game, you're going to need things like animations, punch, kick, moving side to side. We're not worried about things like, you know, the Hadouken or special combos or frame cancelling. All of that comes later. We just need those basic mechanics in and establishing essentially a pre-alpha. It's to say this is more or less what the game is going to look like, or all of the features that we need to build upon moving forwards. Once you've got the core features in, you've reached your first milestone. How long that will take will vary depending on the project. So you also want to establish your unique selling point. This is another thing that the game absolutely must have. Every game should have something that's unique to that product. However, the unique selling point is not always a game mechanic. Sometimes it's character design, sometimes it's visual style, sometimes it's the story. But you need to establish what it is and how it will be implemented. For example, if it is the story, we need to look at narrative design. How is the story being conveyed to the player? Are you going to be using cutscenes? Are you going to be using barks? Are you going to be using character dialogue? Is there going to be limited or special content, like even external, like you can go on the website and read up on lore? These are things that you need to decide in advance and get them done, because they all contribute to the game, so they're part of the game development. Once you've established what your unique selling point is, and once that has been completed and implemented, you've reached a new milestone. Then you have your best selling points. Now, best selling points can be numerous. Generally speaking, I would expect to see at least 2 or 3. but the size of the game and the scope of the game, that might vary. Your best selling points, or what I sometimes say is best, alternate, secondary, etc. These are the things that sell your game that are more commonplace but are essential to making the game fun. So when you are understanding your target audience and you're saying, my target audience are people who like to play challenging, difficult games, then one of your best selling points would be, this game is challenging. So you need, how do you make it challenging? It's going to be maybe a complicated AI mechanic where the bosses or enemies learn from your behavior and adapt to your playstyle. So that would be the game mechanic that needs to be implemented. So that becomes a milestone. When that game mechanic is complete, that milestone is complete. Each of these selling points will be their own milestone. Then you break those down into individual objectives. So using the same example, if we're going to have enemies that learn from you, we're going to need basic combat, we're going to need enemy combat, we're going to need reiterative events, we're going to need different types of attacks. Each attack would probably be implemented separately. We're going to need the progression system, the way that the enemies change. We're going to need the way that they observe and track the player's behavior. All of these individual features that need to be implemented. Some of them will require other features to be implemented first. And in those cases, we refer to blockers, a feature that can't be completed until another feature is done before it. So the smallest possible task that can be completed, we refer to those as stories. The individual tasks that make up your milestones, we refer to as epics. So like I just said, if the best selling point is the game is exceptionally difficult, one of the epics would be having an enemy that learns from the player. One of the stories would be tracking the player's input and creating like a pattern recognition algorithm that then, that by itself is a task. This next task would be taking that input and doing something with it and saying, okay, we're going to give different abilities or going to trigger different upgrades to enemies based on the patterns that have been recognized. So you're going to have multiple tasks to make up an epic. Multiple epics will make up a milestone. All of your milestones together make up your goal, which is the complete game, your vision. I would go into greater detail once you understand what your milestones are, once you understand what your epics are, and when you understand what your stories are, then we can start actually defining them. So part of your planning process, especially if you're doing this properly, is to break these down and then to apply what we refer to as SMART targets. SMART is an acronym that refers to specific, measurable, achievable, relevant, and time-bound. Some of these overlap a little bit, so you have to be flexible in how you apply it. But when we talk about being specific, we're going to say who, what, when, where, why, and which is the specific nature of what it is you're trying to do. So something ambiguous like making the game difficult is not a SMART target. Saying we're going to have an enemy that learns from the player's behavior is closer. If we say the enemy will have a long range attack if the player uses close range combat style, and that is specific. That's a specific action that it will do. It is what it will do and when it will do it and why it will do it. So you need this level of detail when you're creating a task of any size. Then you want to be able to measure it. You want to understand whether it's how long it will take to complete this task, or you want to be able to say what percentage does this task represent of the overall project. So we talked about having multiple milestones. Milestones are made up of epics. So you should have a system to say, when we complete this many tasks or this specific task, we are this distance towards completing our goal. So if we say this will take 2 hours, and we say the project will last 120 hours, then we know that that's how far we've gotten. So you need to have a metric for measuring your progress. Percentage is tricky because it requires a lot of detailed understanding. Hours is very unreliable because people generally don't know how long things will take. Things will take a lot longer than planned. Some things will be completed quicker. So we use a system called effort points, and that's something I'm going to revisit shortly. We talk about making sure it's achievable. So achievable in this context is compare desired outcome to resources available. Yes, you want to make this game with all of these cool features, but is that even possible? Do you have the skills to do that? Do you have the people? Do you have the time? Do you have the money? If you have not got these components, then it's all well and good to say this is a specific action that will take this amount of time to complete, but you literally just can't do it. So make sure you spend time to actually break that down and say, all right, what are our resources? What is our team composition? What skills does our team have? If there's a skill we don't have, is someone capable of learning it? It's reasonable to say that your programmer might be able to learn how to implement 3D animated characters. For example, let's say you have a character, like I've got characters in Science Symphony who can walk. We want to make it that the character can slide across ice. I've not done that before, but the concept is fairly straightforward. It's just kind of combining and reconfiguring other aspects, and changing the animations sequence that's used and the triggers for activating and deactivating it. With that in mind, I'm sure I could do it, but I would have to learn how to do it first. So there would be a time for learning, a time for experimentation, a time for basically when things go wrong, and then the actual implementation time. So when I'm planning a project, I would have to take those things into consideration. Whereas if I was saying, oh, we want to add augmented reality, and the player should be able to access the game by picking up their phone and scanning something, and then using that to send resources to the player in screen, I have absolutely no idea how to do that. I don't know how long it would take to learn. I don't know how difficult it would be. I don't know what software we would need. I don't know what limitations there are. It is an incalculable addition to the project. You can't realistically put that in as a feature if you have no means of measuring it or being specific with what needs to be done. So it breaks the SMART process. So that's why only add things that you can achieve. If somebody is trying to add something that can't be achieved or is unrealistic, make it clear to them. At the very least, make sure that that objective is a low priority, in the sense of everything else will get done first, and then based on the amount of time we have left, we'll try and fit this in at the end. Never make it a priority when it is something that you're not even sure it can be done. It will waste so much time and it will be very damaging to productivity. So that's why achievable is an important one to take into account. Relevant. So I mentioned this right at the start of the stream. Make sure that every feature and every task that you're doing relates back to the premise. So if you're doing a specific task, that task relates back to the epic. When you're doing an epic, it relates to a milestone. The milestones are determined by the core objectives and the core of your premise, and it's referring to core gameplay outcomes, or as I referred to before as positive emotional responses. That is to say, you want your player to have fun. You want the player to have a positive emotional response. How is the feature you're currently working on going to lead to that specific response? If it isn't leading to that response, is it relevant? Is it necessary? Sometimes developers will input Easter eggs or input features that aren't really necessary or will only affect a small number of players. It can be fun, it could be appreciated, but they are very low priority. So when you're doing your planning, consider relevance. How important is this, and is it relevant to the game we are currently making? Like, another good example is, are you building a feature that will probably end up in a sequel or might not end up in the game at all? I've had these conversations with Clark, for example, when we were building, I think, when we were doing the demo for EGX, he was working on the art for an environment that we had no intention of adding to that demo. Yes, one day we will need it, but it wasn't relevant for what we were currently doing. It was outside the scope of what we would consider a SMART objective. He shouldn't have been working on it at that time. So keep that in mind when doing projects and working on the team. Finally, time bound is simply have a specific deadline. Yes, it's hard to judge exactly how long things will take. Regardless, you're going to have a specific deadline. If I think something will take an hour and my capacity is a week, then I should say I will have this done by Wednesday. That is to say, I could have it done by the end of today, but that's unrealistic, and there's probably other things that might come up and get in the way, or it might take longer than I think it will take. So the general rule of thumb is like time and a half. So you say, like, if you think it will take an hour, it will probably take an hour and a half at least. And that's where you would set your deadline. And if you If you're unsure, or if you think it will take an hour and a half, you round it up to 2 hours, then you add the additional hour on top. So if you think it will take an hour and a half, you assume it will take 3 hours because you round it up to the nearest hour, then you add 50% as your deadline. So obviously right now it's Sunday night. I'm not going to do it. I'm not going to finish anything now. If I think a task would take an hour and a half, I would do it on Monday. I have other tasks on Monday. I'm not sure when I would get around to it. And I do not have capacity on Tuesday. Hence, Wednesday is my deadline because it means even if I mess up and don't get it done Monday, I still have time to get around to it, whether that's Tuesday night or rearrange another task or do it Wednesday morning. But it's realistic that I could get it done within that timeline. I have a deadline, but obviously, as I said, I'll try to do it on Monday, and then I don't need to worry about it being late. Keep in mind, as long as a task is too large to be scheduled into a single action or working day, it should be considered an epic. Regardless of what the description says, if it will take longer than a day to complete, it is an epic. And it should be in some way broken down into smaller tasks, that is to say a story, that can then be implemented one day at a time. You should not plan to have tasks carry over into future days. It's also worth keeping in mind productive hours, something I'm going to talk about in my development stream. You generally want to try and break your task down into 2-hour windows. If a task will take longer than 2 hours, see if you can break it down. Because generally speaking, even though you can work up to around 5 to 6 hours without really losing too much momentum, you tend to take breaks at roughly 2-hour intervals. If you're working on something that is quite complicated, when you take a break, you're going to find it more difficult to come back to it, and it just slows down productivity. So try to complete tasks within that 2-hour window, and don't start a task that you know you're going to have to stop midway. Pick tasks that you know are smaller requirements. So going back to being measurable, if you know it will take less time, or if you know it's going to take less effort, you're going to take that larger task, that 2-hour task, and then if you finish it within 1.5 hours, you're going to find a smaller task that's maybe 15 minutes, and then you're going to start that. You're not going to start another 2-hour task when you're expected your work slot to end within 30 to 60 minutes. And keep in mind, what I've done here is I've covered all of these points on a single page, and I've realized what I'm going to do is I'm going to break these down into 5 separate pages, because some of the content I mentioned at the start of this video that I wanted to add, I've already kind of been covering it in these kind of subcategories. So what I'll do is I'll just expand on it a bit more. Because I've got a single page, I'm kind of rushing through it a little bit. So I think I'll be able to break it down a little bit and go into more detail about specific areas I think are important for you to know about. So one of those, for example, was effort points. If I had addressed it in the previous page, it would have just been a little bit easier. Effort points, I've mentioned here the Fibonacci sequence. The Fibonacci sequence is a mathematical sequence of numbers where the next number is the sum of the previous 2 numbers. That does not include the first 2 numbers because mathematically that's impossible, 0 and 1. But from there, after 1 you have 2. After 2 you have 3. 3 is the sum of 2 and 1. The next number is 5, which is the sum of 3 and 2. The next number is 8, which is the sum of 5 and 3. 13, which is the sum of 5 and 8, so on and so forth. This sequence, you're going to hear, I think, the golden ratio. It comes up in nature really often, and for some reason, it's just the way these numbers work. It makes it easy for us to manage and calculate and estimate things, rather than using just even numbers or just odd numbers, or just using other forms of exponential growth. Generally speaking, these numbers do not refer to time, but they refer to effort. They are used to compare tasks against other tasks. If I'm doing a shooting game and I have a character that's going to be shooting bullets, and I would say, oh, I've done that before, I'm going to rank that as a difficulty of around 3. Then I'll say, oh, but I want to have a character that can shoot lasers. That's different animation, different kind of movement speed. I need to consider a different type of collision. It might not be a projectile, instead I might use ray casting. So that's going to be more difficult than the bullets. So I'm going to make that a 5. because it's still similar to bullets, it's not that difficult, so I'm not going to make it an 8. This is how you do these comparisons. The reason we do it like this is because when you're doing that task, which you think is a 3, and it takes you, say, an hour and a half, you know that the next task is probably going to take longer than an hour and a half because the laser shooter is more difficult than the bullet shooter. Then I could say I need to do rockets. Well, actually, rockets are different to bullets, but easier because they don't move as fast. You're less likely to get bugs from high-speed collisions. On the flip side, they require additional animation and maybe things like maybe they don't travel in a straight line, but generally speaking, is either the same or easier than bullets. So it would be a 3 or a 2, depending on the exact nature of how you want this to work. Then I might say I also want to add a teleportation gun. That is an entirely different mechanic, but it requires the same mechanics of the shooting or the laser gun, except instead of destroying an object, it's relocating the character, or it's relocating another object to a location. Then you have to consider all the different ways that can bug out, objects traveling through each other, there's not enough space for an object to go there. So I know that's going to be far more difficult, so I'd rank that as an 8. Because this system is very loose and it's all about being ambiguous, it's useful to have a starting point, something that you could use to kind of gauge how you're going to rank things, and then abandon this system and essentially just do it based on, is it more difficult or less difficult than the previous task I discussed. So what I've got here on the screen is meant to be a starting point, but is not a strict set of rules. So if I say a 0, I generally mean something I've already done, I just haven't documented. If I'm in a meeting, especially a sprint retrospective or a sprint planning meeting, and someone says, we need to get the UI updated so that it shows the different font, and I say, no, I've already done that, I just forgot to tick it off. So it is done, I just need to literally tick that off, that's a 0. If it's something like, it's not done, but I know exactly what needs to be done, then it's a 1. That is to say, all I need to do is change the value from Sans to Comic Sans or something. That's it. That's the extent of the task. Or if it's like the character, he's jumping too high, I'm like, oh yes, I changed it from 3 to 7 when I was doing a test. I just need to change it back to 3. That's done. I already know what I need to do. If the task has a degree of a margin of error, or margin of error or trial and error, that is to say, this character is jumping too high, and I say, yeah, I haven't quite figured out how far we need it to be. Meaning, I instead of before where I said, yep, I changed it from 3 to 7, I just need to change it back to 3. Now I'm saying I need to change it and see which is the best number. So I'll try 2, I'll try 3, I'll try 4, maybe I'll try 4.5. I need to do a few tests to make sure he doesn't like jump into a wall or jump into the ceiling and stuff like that. It's still an easy task, but it's more difficult than the previous one because there's room for error. It's also going to take longer because of that testing process. So that's why it would be a 2 instead of a 1. I usually give a 3 to reworking an existing feature into a nearly identical one. So, like the example I gave earlier, when doing bullets, if I was doing bullets and then I was doing a laser, that's a different feature. But if I was doing bullets and doing rockets, they are the same basic mechanic, or if I'm just changing the ammo. But generally, if I'm making rockets, it has the same kind of code, the same kind of collisions. It's just tweaked in terms of things like size, movement speed, collision box, and stuff like that. So if I'm reworking the bullets into rockets, that's a 3. There is trial and error, there is unknowns, but I have a clear idea of what needs to be done. It shouldn't take me long to accomplish it. If I'm reworking a feature into a similar one, we need to dedicate more time for testing. So this is where we talked about the lasers. In some games you have projectile bullets. In some games you have raycast bullets. So they don't fly through the air. They just teleport to the destination which you're hitting. So they instantly hit the target. You can also add a time delay. So you can see how it could get complicated real fast. But generally speaking, I'm using the same point and click mechanic. I'm using the same hitbox for when the collision is made. It's just I'm going to replace traveling with raycast. I'll need to spawn the object on the point which I'm aiming at. It is a bit more complicated. It is going to be different, but it's still, I have a very solid idea of what I need to do. Hence, instead of a 3, we've now moved to a 5. When I refer to an 8, I'm referring to exploring new territory, something that I have some idea of, but is something that I've not tried yet. So this is going back to my earlier example of the teleportation gun. I know that it would work similarly to the laser caster, or the laser shooter, sorry. But I've also done characters that do need to spawn or relocate or teleport. And I'm aware that some of the problems I'm going to encounter, such as if there's not enough space to teleport, so I need to have like a condition that says you can't go there right now, or it kills you if you teleport there, or you can't move certain objects. This is a new territory, but it's something I have some vague understanding of. That's what I rank as an 8. By the same notion, if I give something like a 5, I'm expecting that to probably take like half the day to do. And by half the day, we're talking about 3 to 4 hours. Where if I rank something an 8, I'm expecting it to take pretty much the whole day to do. Ideally, I should break it down into smaller tasks. But generally speaking, if I feel it's something I can't break down into smaller tasks, it is probably something that I'm expecting to take the whole day to do, because there's going to be research, there's going to be implementation, there's going to be errors, and then there's going to be testing, and that's going to take time. 13, in my opinion, 13 is an epic, but the reason why we use 13, for me personally, is if you have broken down tasks into smaller features, at some point you need to bring them back together. We refer to integration, integration testing, regression testing, times where you're getting multiple features and you put them into a single scene, things tend to go wrong. You can't break that down because it is literally the process of putting it together, so they tend to be longer and larger tasks. You expect it to take maybe a day, maybe it'll take longer than a day. This is the only time in which you should justify using a 13. Under all other circumstances, if you're grading something more difficult than an 8, break it down into smaller tasks. You should not be trying to tackle something more difficult than an 8. The 13 is the exception because you are bringing something back together. And with that said, if you reach the next number in the sequence, which is 21, it is absolutely an epic. There is no justification. This is a task that you need to break down. The only time something might be a 21 is because you are exploring unknown territory and have not done any analysis on it yet, hence you don't know how to break it down. So you need to go through the task of analyzing it and then breaking it down into smaller tasks. So if you're ever working on a team and you see a task and it says 21 as an effort point next to it, it means that this task is not to be touched yet, or it needs to be analyzed, or it needs to be reviewed, and it will be broken down into smaller tasks at some point. If it isn't, then they're not following good practice. Sorry, it's like over the course of this video, I've been developing a code, so my voice is getting a little bit stuffy. So we're going to talk about effective prioritization. My favorite approach to prioritization is to use the Moscow approach, which is must, should, could, and won't. These refer to tasks should be categorized under one of these 4 values. You're going to have a backlog, or sometimes features, which I have here on the left. A good tool for task management is Trello. So this is a Trello board. Industries will often use things like Jira or Confluence, but task management boards are really useful for managing tasks and getting on with things. And once you have one column, which can be on this column might be an epic, for example, or it might be a milestone. But generally speaking, this is your backlog of tasks. Each of these individual cards could be a story, depending on your organization style and the way you deal with things. Each task could be a story, or each task could be an epic, and then you click on it and the stories are going to be inside. There's different ways of doing it, depends on the scope of the project and how much you want to save space or be organized. But ideally, each of these cards should be a task. That way, they're easily managed because you could move them to different columns. If something is a must, for example, we mentioned earlier core features and we mentioned unique selling point, you absolutely need that. You can't not have that in your game. If you don't, your product is incomplete. I like to use the analogy that if you were being paid to do a task and and you do not complete something on this list, you would not get paid. You haven't done the job at all. So core features, unique selling points, basic win condition, lose condition. These are like all things that you must achieve for your game to be considered complete. Things that you should achieve are slightly different because they are extremely high priority, but in the worst case scenario, you can sacrifice them. So using the same analogy, if you were to say anything in your must column is not done, you don't get paid. If something in your should column is not done, you will probably get paid, but you will lose that client. That person will never come back. They'll never work for you again. It is serious, and it is something that should be taken seriously. But if you, there's no way around it. There's no way around it. So you just need to understand some tasks you feel like they should be in the must column, but they're not. They are a should column. And there is a reason why we do that. It is to make sure that you do know there are certain things that are absolutes. After that, so I will mention things in the should column, your best selling point, for example, having things like a tutorial is a should, having a basic, start sequence and ending sequence, credits, audio, animation. These are things that are shoulds when it comes to video games, because you can get away with static images, you can get away with like bad startup screens, but the game will just look really unprofessional, and it will usually just not. It will look like a demo, or like a school project. It won't look like a professional level project if you don't include some of those elements. The could list are the bonus features. They are the things that you know will make the game better, but you might have to sacrifice if things go wrong. We mentioned you will have your best selling point, and that's something that you should do. We mentioned earlier that you'll have more than one selling point though. You might have your secondary or your tertiary selling points. So anything beyond your absolute best selling point would go on the could list, because these are things that you want to get done, but you can sacrifice. The game will still work without them. The way that I use the same analogy as before is, if you don't have anything from your could list, you will probably lose the client, or they will basically look elsewhere. That is to say, if you have a player plays your game and they're like, it wasn't bad, but it just wasn't good, they might play it again, but they will easily be distracted by a better product. It's not the end of the world, but ideally you want to get in that positive experience that makes them recommend the game to someone else. And then that's the opposite point. If you finish this list, then that player is going to have the best possible experience, and they're going to recommend that game to other people, and you're going to find that your sales and your productivity skyrocket as a result. That is how you should view the could list. These points are usually quite easy to understand. The one that people tend to underestimate is the won't list. Sometimes in development, you have to establish there are things that you simply cannot do. Most people treat the won't list like a could list. They say, I won't do that unless something happens, and then I'll try and do it later. The reason why you don't do this is threefold. One, is bad practice in general. If you have extra time, refine something else. Meaning, if you've got something in your could list that is done, go back to it and see if you can make it better. There's always going to be room for improvement. So if you've taken something and said, I can't do this, leave it out. Focus on the things that you said you would do. Just if you have bonus time, focus on making them better. Second reason, if you have that extra time at the end of a project and you think you can squeeze in one more task, you have to take into account regression errors, integration errors, last minute bugs. You're likely going to break your project, or you'll end up adding a feature that is low quality. If you've ever done like an art portfolio or heard someone judge one, they say do not add everything you've ever done, only add the best of what you've done, because the worst thing in your portfolio is going to be the thing that they remember when they're judging it. So keep that in mind, that you could squeeze in one extra feature, but if that one extra feature is bad or buggy, then that might be the one thing that makes people hate your game. It's not worth risking trying to squeeze something in at the end just because it might make it a little bit better, because more likely it will make it worse. The third reason, and this is mostly if you are an employee, so this is one of those key points that came up a lot when I was talking to my apprentices, is you will have people tell you to do things that you can't do. They haven't given you enough time, they haven't given you enough resources, you don't have the skills. They will be upset if you tell them no. They will be far more upset if you tell them yes and then fail to do it. The power of no is incredibly important when it comes to project planning and project management. Be able to say, I can't do this, not only does it set good expectations, it also means that if your boss or your employer or your client says we need this, they understand that that means they have to sacrifice something else. Something else on your could or should list has to be downgraded for something on your won't list to get upgraded. So you're giving them the power to make that decision. Another thing about that is, if you do add things from your won't list, it sets a bad precedent, because now your employer will think, okay, he can do it. So on a future project, if you say you can't do something, instead of them respecting your decision, they're going to assume you're going to do it anyway, or they're going to think you've underestimated it. And that puts you in a bad spot. It means that your future projects are going to be more difficult because that one time you tried to show off and throw something in there that you weren't supposed to put in there. So set good expectations, set consistent expectations. Don't go above and beyond if it puts the project at risk. That's why I always emphasize the want list. I think a lot of people just underestimate how important it is, but it trips up a lot of people, especially junior developers, apprentice developers, but also sometimes senior developers. They struggle to say no, and they find out it comes back to haunt them, and it tends to just get worse over time. Once you set that bad precedent, it continues to grow throughout your career. It's very difficult to go back on that. I know managers who are still having trouble saying no to people, and are stressing themselves out, doing unrealistic amounts of work, doing unrealistic and unhealthy amounts of overtime because they kept going above and beyond, and they've struggled to now take a step back and return to a healthy level of work. So you have to be careful with things like that. All right, so I think this is like the last major point I want to go through. It's a little bit boring, but it is important. Again, it's one of those areas that a lot of junior developers and a lot of new starters at companies and they struggle with, because when you're doing compulsory education, and if you are learning about programming, most of the time you're learning independently. As soon as you start working with other people, which is going to be 90% of the time when you actually enter the industry, standardization and documentation become a lot more important. So keep in mind, you need to document your plan. I use Trello a lot. It's a free tool, but if you're working for a company, they might have enterprise level tools like Jira or Confluence. It allows you to organize tasks really well, and I'll probably do a separate video just to kind of show how to use it as a method, or I'll do it when I'm doing my general streams. Google Docs is a useful one because unlike Word, it's online, it's easy access, and it's free. I can put one Google Doc, which might be the premise for a game, and then all members of my team can see it and reference it. Every day we can do a stand-up, and I can load that up in the back and say, everyone look at this. This is what we're referencing. Same goes for a game design document. It's useful to have that on the cloud and with everyone having access to it. I've actually found calendars are really powerful tools for project management. If you use reoccurring meetings to update events and activities, it essentially works like a task board. The calendars already have inbuilt tools like reminders. You can invite people to different events. You can duplicate them if you have something that you're doing multiple times. So I usually have, say, a stand-up like every Friday, and I'll put the things that I need to cover in that stand-up as a reoccurring meeting. So if we don't cover something, it will stay there for the next meeting. And if we do cover it, I can delete it and it will update every future meeting, so it will no longer be there. It works in a very similar way that task boards do. So calendars are a useful tool for just kind of organizing your time. When it comes to programming specifically, but you can also use this when it comes to files, you need to understand naming conventions. Variables will typically have one of four naming conventions. There's camel case, where the first character is lowercase and every first character of a new word is uppercase. So here we've got camel and then the C in case. Pascal case is every word is capitalized, but not the entire word, just the first letter of every word. Snake case separates words using an underscore, and kebab case separates words using a dash. It's worth noting, kebab base is pretty much only used for web development or website URLs and stuff like that. Snake case is also fairly uncommon, but some people prefer to use it, so you might come across it. The general rule is, if you are entering a company and they are using that notation, you should also use that notation. It should be consistent so everyone does the same thing. But the main two is camel and Pascal case. Generally speaking, most people use camel case for general variables. So if I have a variable called hit points, it would be lowercase h, uppercase p. But if I have a method or a class, I will capitalize both the first and all subsequent words, first letter of the words. The reason why we do that is because somebody will look at that and immediately know that is a object, or that is a class, that is a method. It helps them to recognize and read code more efficiently. Sometimes if I'm using like custom objects like enums, I will have the enum might be I don't know, object type, and then the variable could be object type but with a lowercase o. So they use the same name because it is case sensitive. It recognizes if you use the same name, but because sorry, it recognizes if you use different letters, different cases. But for you, the human being, you'll see that they have the same name, so you know immediately that this object is referring to a child of that object, or this is an instance of that object. So again, it just makes things more readable. It makes it easier and quicker to understand. Similarly, you have to follow these kind of protocols when you're doing any kind of documentation. So if I have files that I'm saving, you want to save them using the same naming conventions. If I have tasks, for example, on my task board, I could say task underscore the name of the parents or the story. I could have the story as the lowercase and then the uppercase is the epic, or I could have task bracket 21, and the 21 represents whether it's in the effort points. There's again, it all comes down to whatever the standard process in that company is, you want to follow it. I think in the future what I'll do is I'm going to add some samples to the screen so I can just like show you visually the types of things I'm talking about, because it's easy to forget these kind of details, or it's easy to miss it without examples to reference. But I've got a brief one here. If you are doing executable files for your game, we talked earlier about milestones. So I would say if you're working on your core features, you might have the name of your game version 1.1. If you add if you update the core features, it's 1.2, 1.3, 1.4. But when you finish the core features and you're moving on to now unique selling point, you are at version 2.0. You have reached that milestone, and you update the naming convention accordingly, which means that you usually be finished somewhere around game version 4 or 5.0. Sometimes people will use more points, so it'd be like 1.1.0. If you ever get like download Unity, you know that Unity version 2023.5.6. So they have like the year, then they have like the month, and then they have like the specific iteration. Sometimes they use numbers and letters, so it might be version A.1 or it might be 1.A. It doesn't matter which way you do it. What matters is that you're consistent. That is the only real thing to keep in mind, that you're consistent and it makes sense. It's not just about because you're working on a team and you need to show, you need to be able to work with other people and they need to understand what you're doing. You need to understand what they're doing. And again, this is something that most junior developers struggle with because most of them work independently. For the same reason, it's also about maintenance. If you're working on a project and you're doing something now, what's now, August, and you come back June next year, all of these little things that you would normally remember, you're going to have completely forgotten. If you're looking at your code and it does not make sense, it is going to give you a headache. The better naming conventions you use, the better file management you use, the easier it will be to pick up code months or even years later and continue working on it. And again, as I said, the same reason, most junior developers are working within an academic year, meaning they're working on a project. Usually they start in maybe October and they have to finish by January, or they start in January, they have to finish by June. It's rare that you're going to start a project in October and then you're going to continue working on it October the following year. Hence, that concept of maintenance and long-term future-proofing your code simply doesn't apply when you're in compulsory education. But as soon as you enter the professional environment, everyone will expect you to maintain this. So there is a big jump in terms of expectations from education to industry, which trips up a lot of new starters. And you don't always notice it straight away because you might do something that to you makes sense, and it's not until a year later that suddenly everyone is screaming at you because your code is terrible and no one understands how to fix it, or you're getting bad reviews because someone else is meant to be working on it. You've been given a different task. A new starter was given your old code, but they can't understand your old code because it was very poorly written, and now you're being pulled off of your current task to work on the old code because you're the only person who might be able to understand it. This is real life horror stories. I've experienced this. Pretty much everyone I've ever worked with has experienced this. Hence why I emphasize it as part of this talk, because I feel like if people get a bit more experience doing this earlier on in their careers, they're less likely to have the horror stories where some people get fired over this kind of thing. Like, it does get quite serious. Um, but it's also quite common because people just don't learn until it's too late. So that pretty much wraps up the core things I wanted to talk about. So the benefits of a good plan is just better organization. It's easier to apply time management. It adds more consistency to your project. And I think the most underrated point here is its uninterrupted workflow. A good plan means that you work the hours you want to work for as long as you want to work. You don't get disrupted. You don't stop midway. You don't lose track of what you're doing. You don't end up miscalculating how long it will take because you plan to do something on a Wednesday and then you ended up doing it on a Thursday, and then the thing that you're going to do on Thursday gets pushed to a Sunday. Those are all real issues that you experience in agile game development. The better you're planning, the less it happens, and this is why the waterfall game development strategy is to spend a huge amount of time planning, so that you have almost no interrupted workflow, you have almost no inconsistency, no unpredictability. But with agile, you're doing things a little bit faster, you're doing things with a bit more flexibility, so things are more likely to go wrong. So you just want to have enough of a plan that you can keep things going smoothly without having to spend literally months on just planning. Generally, with the agile approach, we might spend one full day doing a plan. At the very start of a project, we might spend like a week, but generally we spend one day doing a plan, then the second day like for the project, and then another day for the sprint. And we talked about sprints in our previous stream. Whereas with the waterfall approach, you will literally spend weeks, if not months, planning, because they do all their planning in advance. In agile, we do planning in waves. Every 2 weeks, we update the plan, so it's an evolving process. The cons, it is a bit time consuming. Whether you do it all at once or whether you break it down into steps, it does take time, and time is money. But if you don't do your plan, you're probably going to lose more time anyway. So if you're doing a small project, like just like a school project, if you're doing a little test, you could get away with not planning it. But if you're doing a commercial level project, if you're doing a project that's going to take more than a month to complete, then the lack of planning will lead to more time being consumed. The old phrase, failing to prepare is preparing to fail. Planning does have a drive for consistency. You need to be consistent with what you're doing. If you are not consistent, the plan won't work. It doesn't matter how good your plan is if you don't adhere to it. That also usually means having stand-ups or having regular meetings to make sure that people are on plan and are following the plan. Usually the job of a product manager or scrum master or designer is to make sure everyone is basically following the plan and, by extension, the premise. You need to have clear and consistent communication. If you have bad communication, again, it doesn't matter how good your plan is if you don't communicate it effectively. This is not just about talking to people in verbal communication. It also goes back to, like I said, the tools that you're using. Are you linking people using the cloud? Are you using emails? Do you text? Do you have phone calls? How you communicate the plan and how you make sure people are regularly checking and doing updates affects its usefulness. And by extension, a plan has a reliance on tools and resources. It doesn't matter if you do a plan if it's all in your head. You need to use tools to implement the plan. You need to have strategies. Making sure people have access to, most big companies make sure everyone has a smartphone, everyone has their own personal laptop, because they need to have access to tools consistently. If they're using their own personal tools, their own personal phones and their personal computers, they might not have the tools like Jira or like I know Monday.com or whatever. So to make sure everyone has the same tool and for consistent communication, you usually have to make sure everyone has the same resources, everyone has the same equipment. It does require good management skills, but the thing I'm going to add at the end of this is these are less cons and more things to be wary of, because if you do not have these things, you're going to struggle anyway. You can't say, oh, I'm not good at being consistent, so I'm not going to bother making a plan. What you should be saying is, I need to get good at being consistent so that I can have a plan. Because if you're bad with consistency, you're bad with the project regardless. It doesn't matter if you rely on a plan or not. Because lack of any of the above things I've just mentioned is going to be detrimental to your project. Uh, I want to like finish up by just saying this is a overview of planning. Um, when I do like workshops, we'll go over the details of a game design document. That process could take anywhere between like 2 to 4 hours to properly go through. This video, this talk was designed to be less than an hour, just so that I could essentially cover it in a single class. Originally, I wanted it to be half an hour. My old video used to be 2 hours long, and I realized it was just too long. It's too much information at once. So I've only covered the most important and essential things that you need to know. Um, I would recommend either joining me for my development streams or coming into one of our workshops if you want to know more about good planning practices and development practices. Um, we do cover the full software development life cycles during our workshops. So my previous video was on the premise. This one was about planning. My next videos will be on develop, testing, and release, like in sequence. I generally don't do a maintenance video because it kind of has its own unique requirements. It's just not necessary to do a separate video on that. But I might incorporate it as part of one of my other streams. So I'll go through each of these processes just to give you a taster of each one. But generally speaking, when we do our boot camps or our courses, we go through each of these in a lot more detail. So either we have a full class or we do like a full day, breaking it down, going through the designer, implementation or developer process, as well as the quality control and marketing processes. If you want to know more about that, we host events usually in London. The majority of the time it's South London, like Wandsworth area or Bromley area. But we also have a venue in Hoxton that we use as well, and one in Tooting. You can find out more about that on our Eventbrite page, or if you follow us on Instagram or any of our other social medias. We do regular updates in regards to our different events. Most of them are free to attend. Only a handful of them are exceptions to that. So have a look if you're interested. And that's pretty much it. I think that wraps up everything I wanted to go through over today. I did mention that I was